to wrap up with some sequences and series, because obviously the arithmetic and the geometric are really the bulk, and we didn't get to get to those. So I'm not necessarily going to do everything I had prepared for us to do, but I do want to do at least a geometric and an arithmetic, just so that we've done it. We can have a conversation about what we need to know. We did speak about the arithmetic when Lorato asked this really nice question in terms of quadratics, and how sometimes we can ask you about the difference in a quadratic sequence, and we need to understand that the first differences of a quadratic number pattern do form an arithmetic or linear number pattern, and then we can go from there. Alrighty, but we are going to do that. I'm hoping, wham bam, thank you ma'am, and then we will get into our stats and analytical. Also, hopefully, wham bam, thank you ma'am, but I'm going to get into it. So if you have questions, please ask. You can put them on the chat, you can raise your hand, whatever you need to do, you know this. But I'm just going to get straight into it. Okay, so this question here, we have a finite arithmetic series. So firstly, finite means it ends. Now, generally speaking, when we tell you that it is finite, we will generally either tell you how many terms it has. Let me make this bigger. This seems ridiculously small. Yeah, there we go. Now I can actually see what I'm doing. That seems ridiculously big. Okay, anyways, whatever. Right, so if we tell you it's finite, generally what we're going to tell you is where it ends, or what term it ends with. In this case, I'm telling you that it ends with term 124. So we don't know which term number it is. We don't know if that's the 40th term or the 12th term, but we do know the value of that term. Okay. It's a series, so we are potentially going to be looking for the sum of, or some sort of sigma situation. But the first question says, determine the general term of the series. Excuse me, in the form Tn equals Dn plus C. Now, guys, that whole Dn plus C, all it means is write the general term in simplified form. Okay, we obviously know from our formula sheets that for an arithmetic series, and I did write it out on Monday, but just so that we have it again, Tn is equal to A plus n minus 1 times D. Okay, all we want you to do is, once you've substituted in there, you actually need to simplify it and get it with the n term and then your constant term. All right, so this is a 2-marker, if I'm not mistaken. 2-marker. I'm going to give you 2 minutes to work out the general term for me, and then we'll have a look. Lelo, I see your question. I don't see any questions posted on the Google Classroom. Oh, wait, I'm just a bit silly. Okay, I do see them. I will have a look, and if we've got time, I'll chat to you about them in the lesson. But if we don't have time, I will have a look and put the answers on the Google Classroom for you, okay? Feel free. Okay, guys, let's have a see here. So for the most part, arithmetic, you can actually do by inspection if you want. You don't have to use this formula. I have used the formula here just so that you can see how you can use it, but you can see that you're adding 5 each time, so you know it must be 5n, and then you can go and work out your constant from there. So it is absolutely fine to use inspection, but obviously you do have a formula, so your marks would be substituting into your formula and then the final answer. If you just go straight to your answer, then it's a full 2 marks for the answer. All right, so relatively straightforward, nothing too tricky there. 2.2.2 is not a hard question. It's just because it's asking us for sigma notation. Again, sigma notation is just something that we struggle with a little bit in sequences and series. Alrighty, excuse me. So it's asking us to write the series in sigma notation. It's not asking us to find the sum or anything like that. It's just asking us to write it in sigma notation. And so what that means is we need to go back to sort of our summary notes where I spoke about what sigma notation actually is and what each of the elements of sigma represent. Okay, so at the top, we have the last term that we add, the bottom, the first term, and then we need the general term. Now, we found the general term, and when you have to write a sequence in sigma notation, we'll always start that it's, we'll always assume that it starts at the first term. We start adding from the first term. So we can fill in a bunch of information so far. We know that we've got 5n plus 4, and we know that we're going to start adding from the first term. So at the bottom, n is equal to 1. What we don't know, however, is the last term in our sequence that we add. We need to go find that. However, we do know the value of the last term in our sequence. So we know that t of some value or t of some position is 124. And so we can go and solve for n by substituting into our equation and figuring out which term has a value of 124. So we would subtract 4 on both sides, giving us 120 equals 5n. We would then divide both sides by 5, telling us that n equals 24. So remember, because it's a finite series, we're adding up to the 24th term. And so now we know the number on top of my sigma should be 24. And that's it. You've written everything in sigma notation. Nothing more, nothing less needs to happen here. This was a 3-mark question, so you're getting a mark obviously for figuring out your n equals 24. Those are 2 marks, substituting in the 124 for n and getting n equals 24, and 1 mark for writing it in sigma notation. Right, we could then ask you a follow-on question in terms of what is the sum of this series, and I am actually going to ask you to do that. So what is, or determine the sum of this series. And so now you need to use your formula, and I want you to essentially add those 24 terms. Right, so I'm going to give you 2 minutes to do that, and then we'll have a look at what that answer should be. So what is the sum of this given series? Lelo, sorry, if you don't mind, if you have it, if you don't have it, it's really not the end of the world. If you don't mind telling me what the mark allocation for those 2 questions were, it just helps me think. If you don't have it, really don't stress. I'll figure it out. But if you have it handy, let me know. But if not, no stress. Alrighty, guys. So I have put the formula there for you. Obviously, it's on your formula sheet, so you don't need to stress too much, but it is there. So n is the 24 terms that we're going to add, divided by 2 over 2 times a. A is your first term, so 9, plus the 24 minus 1. You could just write that as 23 if you wanted to, times your constant difference, which is 5. Chuck that all into your calculator, and you get your answer. Oh, sorry. I'm kind of just gonna go with your answer here, but I suppose I better do it as well, Poppy. One, 5, 9, 6. Perfect. Thank you, Lelo. I see you. Thank you so much. I will have a look. So 1,596. All right. So sum formula, all you really need is how many terms you are adding. Obviously, we could ask you to find n. I could have given you the sum and asked you to find n. So you can potentially be solving for one of your variables. But, excuse me, that's it. All right. So if you want to take a screenshot of those two, there it is. And then let's have a look at geometric. Okay. All right. So 5, 10, 20 is a geometric sequence. We want to determine the nth term. All right, so remember, guys, geometric is where we have a constant ratio. Constant ratio you can find by taking term 2 and dividing it by term 1, or term 3 divided by term 2, term 4 by 3, etc., etc. Right, we do have a formula for the nth term of a geometric sequence. Again, it is on your formula sheet, but if we've forgotten, Tn is equal to a times r to the power n minus 1. Alrighty, so this was 1 mark. I'll give you 1 minute to tell me what the general term is, and then we'll have a look. Alrighty, quick and easy. What's quite nice with these ones, guys, is you don't really need to simplify anything. Obviously, everything's going to fight with me. So you do need to know A, which we have. We do need to know R. Like I say, you just divide consecutive terms. We get R as 2, and you chuck it in like that. That's it. Right, 3.1.2 says calculate the sum of the first 18 terms. So this is a 2-mark question. I know you can't see the mark allocations just because I've moved over. 2 marks. So I'm going to give you 2 minutes to work out the sum of the first 18 terms. Your sum formula for geometric, S of n is equal to a times r to the power n minus 1 all over r minus 1. This minus 1 in the numerator is not part of the exponent. The only exponent, or the exponent, is only n. Okay. Again, it is on your formula sheet, but 2 minutes, let's work out the sum. Alrighty. So sum to 18 terms. Which, oh, that's a weird looking 8 in the numerator there. I do apologize, but that is indeed an 8. Substitute in n equals 18, and then obviously your a and your r, which you would have worked out for the first question, and you get your sum to 18 terms is 1,310,715. Now, guys, this makes sense, okay? This isn't a converging series because of the fact that it's getting bigger and bigger and bigger. We spoke about on Monday that a converging series is when the values you add get smaller and smaller and smaller and smaller to a point where you're adding such a minuscule amount that you actually just converge on or approach a specific value. Now, converging series, and you'll see in 3.2 when we have a look at that now, converging series are ones where your R value is a fraction, positive or negative, but a fraction, because it gets smaller and smaller and smaller and smaller. Right, Lorato, do we need to separate the numbers? Assume when you say separate the numbers, you mean just write it like this. That's obviously absolutely fine. I just prefer to separate my numbers into groups. Also for me to be able to say the number, it just makes it easier for my brain. But no, you don't need to separate them. I do, but you don't need to. Okay. Right, so let's have a look at this next one. Again, I don't think this is a particularly hard question, 3.2, but it's reading the question with understanding. So it says, the first and second term of a geometric series is given as 2x minus 4, so this would be term 1, and 4x squared minus 16, respectively. So that's term 2. Determine the value or values for x for which the series will converge. So we're saying it will converge. We just want to figure out at which values. Now, what's really important is that we remember this inequality. Anytime we're talking about that's trying to be an arrow, but failed. Anytime we talk about a converging series, we are talking about this inequality. So first things first, when I get a question like this, is I need to know what R is, because I need to know what R is to put it into that inequality so that I can see between which values it will converge. So R is determined by taking term 2 divided by term 1. And so that's what I'm going to do. Term 2 is 4x squared minus 16 over term 1, which was 2x minus 4. Now, grade 12s, yes, technically that is R, but it's not simplified. At this point in your mathematical journey, you should be able to see that in that numerator, I have got the difference of squares. And when I go and factorize that difference of squares, the two brackets will be 2x plus 4 and 2x minus 4, which means that I can cancel out that denominator. So already you almost need to be thinking 2 steps ahead of yourself so that you can see where your simplification is going to be. Right, so I'm going to factorize that difference of squares. As I said, what that now means is that I can simplify this entire situation by dividing the 2x minus 4 and the 2x minus 4. And so now I have a much easier R value to work with, which is 2x plus 4. Now I can go to the converging situation. So I know that this R value that I've just found, 2x plus 4, must be greater than -1, but less than +1. And now this is just solving a linear inequality. We're going to subtract 4 on both sides, so -5, 2x in the middle, -3 on the right. And then I'm going to divide everything by 2, so -5 over 2, x in the middle, -3 over 2. And between these two values, so -2.5 and -1.5, is where my series will converge. Okay, it said determine the value or values for x. I've given the range of values that it will converge at. And so as long as in this series, the x value is somewhere between those two values, we will have a converging series. So your mark allocation here is working out your R value, remembering the inequality and substituting into that inequality in place of R, and then getting your final answer in terms of that inequality. All right, so like I say, in terms of converging series, the inequality for R, super important, and potentially asking sum to infinity questions, but sum to infinity, not super problematic once we know what our A and our R values are. So from this point, I could say, if x equals -1, determine the sum to infinity. And then you would just substitute in to get your term 1 and your term 2, and you would solve from there. Lorato?
Ma'am, in the question 3.2, do we need to show the convergence inequality? Or can we just like move to the step that you marked whereby you said -1 is less than 2x plus 4, but it's more. Oh, yeah. Okay.
Yeah, it's fine. We'll just give you 2 marks there. As long as we can see that you've understood that it needs to fall in that range, it's fine.
Oh, okay. Thank you.
Yeah, sure. So, guys, essentially what Lorato's saying is, do you have to write this? Can you not just go straight into the substitution? Absolutely. As long as I can see that you know it must be between -1 and 1, it's absolutely fine. All right, let's take a screenshot. Alrighty, so that is geometric, that's arithmetic, really not super stressful. We just have to read questions carefully, and we need to then be able to apply our formulas. That's why I say to you guys, particularly in paper 1, sequences and series in finance, it is application of formulas. Where we trip up is we don't read our questions carefully or properly, and that's where we make silly mistakes. But read carefully, and it's application of formulas. Right, Leila?
Hi, ma'am.
Hi.
Ma'am, I wanted to ask, there where it says converge, you wrote a -1, like R is less than -1 but greater than 1. So do you get a mark for knowing that, or like for writing that on the side? Like, you know what I'm trying to say? Like for knowing that, or for putting it?
It's more for knowing it. It's more for knowing it. So this doesn't have to be written down. As long as I can see that you know that the inequality must be between 1 and -1, it's absolutely fine. You obviously are welcome to write it down if you want to, but you don't need to, as long as I can see in the inequality that those are your restrictions.
Okay, and so ma'am, do you get a mark for writing the 2x plus 4 is greater than -1 and less than 1?
Yes.
Or
so that is this mark over here.
So but then it says the 4 marks.
Yes, so it's 1 mark for working out R, 1 mark for knowing that it's the inequality between -1 and 1, 1 mark for substituting R into that inequality. So if you aren't going to write this bit down, you'll get 2 marks here, and then 1 mark for the final answer. No, that's okay.
Okay, thank you, ma'am.
Sure. Alrighty, guys, so let's get into our stats and analytical for the day. So I did say to you that I'm not going to spend a whole lot of time going through the summary of what we know. We can screenshot and we can move on, just because obviously practice makes perfect. I will point out a few things, but realistically, this is everything that you know already. Okay, so in terms of stats, the most important thing I can say to you is know how to use your calculator. Okay, you need to be able to calculate the mean, standard deviation, R, least squares, regression line. If you can't use your calculator, stats is going to be very, very tricky. On Google Classroom, in those info packs that I put there, I have given you, I'm pretty sure I'm going to feel like a bright nana if I didn't. I've given you a step-by-step breakdown of how to go and determine each of those things. I'm just going to, double check myself here. Yes, I've told you exactly how to use your calculator. I put step-by-step instructions of how to calculate your mean and standard deviation, step-by-step instructions in order to calculate least squares, regression line, and your R value. Okay, so it's all there for you. If you don't know how to use your calculator, please go learn how to do so. That's going to be the most important thing for you. Stats is calculator work. Right, the other thing that you need to be able to deal with is ogives. Okay, so these are cumulative frequency graphs. Again, ogives are not tricky at all, but understanding and knowing how to draw them, that's where we fall apart a little bit. So again, I've given you a breakdown of how to draw it here. We are going to draw an ogive in a second, so we will do it together, but you need to be able to draw them. The little block on the side is just a summary of your R values and the descriptor that would go along. So if, let's say, for example, you found, or you were asked to calculate the value of R, and you found R was somewhere in between 1 and 0.8, so I don't know, 0.96. Your descriptor when they say, what does the correlation coefficient mean? Describe the trend, describe the relationship, would be positive, strong, and linear. That is the descriptor that needs to go with it. So I've just done a little summary here. We did do it in class when we spoke about stats, but there it is again. Right, so if you want to take a screenshot of that, you can do so. And then, guys, in terms of analytical geometry, again, much like the sequences and series and the finance, it's application of formulas, okay? It's application of formulas and understanding the properties of quads, all of which I'm going to show you now in a second. Okay, so analytical, I would really like to be able to get all of this in one shot, but we'll see how we go. There we go. Okay, so analytical, it is, in terms of your formulas, gradient, midpoint, distance, angle of inclination, circles. Those are your 5 formulas. All of them are on your formula sheet. So it's not something that you have to memorize, nothing like that. They're there. Okay, so circles is the newer thing. The gradient, midpoint, and distance formula you've been doing since grade 10. Circles is new, and maybe angle of inclination. But angle of inclination is a grade 11 concept, so it shouldn't be too new. The only thing I will say here is that just remember with circles, sometimes you need to complete the square in order to find the equation. And so please know how to complete the square. That's going to be really important. But the other thing I want to say about analytical geometry is you need to know your quadrilateral properties. You need to. You can be guaranteed that you're going to be asked something to do with a quadrilateral. Either I'm going to tell you a shape as a quad, and you need to know those characteristics so that you can apply them, or I'm going to ask you to prove that something is a quad. And again, you need to know the characteristics in order to prove it. So the properties of your quadrilaterals, so important. Okay, what I will do in a second is I'll zoom in on that in case you want to take a full screen screenshot, but you have to know them. All right. Yeah, there's not much more I can say about that. Right, then just on the right-hand side for the circles, this is generally the complex problem-solving question that we ask. And I'm going to be honest, for me, this is probably the hardest section analytical, but probably just because I haven't spent enough time practicing it. Okay, that's realistic and the reality for me. Oftentimes, we will ask you to either translate or transform a circle in some way and ask you questions about that. But oftentimes what we do often ask is whether or not circles will intersect, fall within each other, etc., etc. And this is just a nice little summary of how to go and determine whether or not they do. All right, so if you want to take a screenshot of that, do so. I will zoom in quickly on the quads and then on those 2 circle things if you would like clearer images. And then we're going to, again, get straight into it. Okay. So first up, your quads. Don't know why I said first up your quads. Let's do the circles first. Okay, so there's just a summary of your circle characteristics about particularly this little blocky over here, particularly useful, just in terms of whether or not circles intersect with each other. I'm just waiting for screenshots. That's why I'm just not talking. Okay. And then your quads, again, you've been doing this since grade 10, so we should know, not even grade 10, grade 8. So we should know our quad properties, but I do accept that sometimes this is something that is neglected. So these are your quad properties. You need to know them, particularly the first 4. That's their parallelograms, rectangles, squares, rhombi. Kites, kind of, but particularly those first 4 you need to know. All right. Then just in terms of the types of questions you can get for stats and analytical, I don't know why I just said stats. So stats, it's kind of split into 2 parts. Stats is 2 questions, question 1, question 2. Question 1 is generally grade 11 stats, so mean, standard deviation, ogives, etc. And then question 2 is generally the grade 12 stuff. Least squares regression line, R correlation, all of that sort of stuff. Analytical geometry, we generally have a basic question which just find the gradient, find the distance, nothing too stressful. Angle of inclination, sometimes they are not very tricky. Sometimes they're slightly trickier questions. Angle of inclination, sometimes they are incredibly straightforward. Knowing your quadrilaterals, as I've already emphasized, and then a circle question. You are going to get a circle question. Just embrace it now. And generally speaking, like I say, understand how to complete the square, understand transforming a circle in some way. So I'm just going to wait there for you to screenshot, and while I do that, and Tori saw question.
Ma'am, I just wanted you to go back when they're done taking screenshots because the network was.
Where do you need me to go to?
I think it was the circles, the one which was on the side.
Okay, cool. I'll go back there now.
Thank you.
Pleasure. Okay, I assume we've got this. So the circles. There we go. Hang on. Right, there we go. Cool. Okay, now again, particularly because these are both paper 2 concepts, grade 12s. Paper 2, the bulk is trig and Euclidean. Trig, Euclidean, and analytical. So stats, you should be getting full marks. Analytical, you should be getting full marks. Or at least 70-80%. Okay, just because those are the 2 sections where you can bank your marks and you can make sure that you get a good foundation for yourself and you can build up from there in terms of the trig and the Euclidean geometry. All right, but let's have a look at some questions. Ooh, okay. Let's just make this big enough so I can see what I'm doing. Righty. So this was the trial paper just written in the Western Cape. For some of you, it would be familiar, for some not. Obviously, all the 2024 trial papers, some of you would have seen, but let's have a look. So it says, during a congress that took place in July, the ages of 100 members who attended were recorded in the following table. So there it is. It's grouped data. We've got all of our intervals here. So we don't necessarily know the specific ages of each individual, but I do know in which age group they fall into. And the first question asks us to calculate the value of A. Now, this is a 1 marker, nice and easy. So I'm going to give you 1 minute to work out the value of A for me. Nice, guys. Alrighty, so in order for us to get A, we know that if we added up all of these values, we must get 100. So we would just subtract all of those values from 100 in order to get A, and exactly A is equal to 16. 1.2 says write down the modal class of the given data. Again, nice and straightforward. Modal, mode, the interval or the class interval with the highest frequency. That would be this one of 37. And so that would be the age group 45 to 55. Right, so like I say, first question generally off the bat, nice and easy, straightforward. 1.3 asked us to complete the cumulative frequency. Now, obviously, I've drawn it beautifully here in the table. You get an answer book for paper 2, and so there will be a little table there. You just fill in the missing cells. So cumulative frequency, remember, it is the accumulation of your frequency. And so essentially what happens is the first frequency remains 8, but now our next frequency, it must accumulate. So we'll have 8 plus 14, which is 22. And then we'll have 22 plus 22, which is 44. And we keep adding and accumulating until what we should get right at the end is the total that we have, which is 100. Right, so quickly for me, like 30 seconds, what are the missing cumulative frequency values that I need there? Nice, Miss Latzi. 81 and 97. Right, just so that you understand the mark allocation here, obviously the first two, the answer, is 1 mark. But here you get a mark for the 8 and the 22. So understanding that your first value is the original frequency and then the addition. Obviously, if you can't add the two together, you can't add any else. So it's just then another mark for all of your other values. All right. Oh, God. Sorry. Golly gosh. Right, so nice and straightforward. 4 easy marks straight off the bat. Question 1 was sorted. Now we get into needing to draw our cumulative frequency graph. So I am going to do this with you just so that we all understand how to draw one. Like I say, it's really not hard to draw one, but we do need to understand how to do so. So, Nokubonga, sorry?
Ma'am, can you please go back like a little bit? I just wanted to get the model classes and all that.
Oh, sorry.
To the table. Thank you. Just 2
Yeah,
minutes.
guys, sorry. I realized that I probably should have screenshotted. I do apologize. That's on me. Okay, let's maybe screenshot those first 2, and then we'll have a look at the O drive while you are screenshotting. So O drives, I think we can plot it. I think there's no problem plotting. It's the grounding that often is the issue. So when you ground an O drive, basically grounding means the point at which you start. Your grounding has to be the lower limit of your first interval, so 15, and its cumulative frequency is 0. So we start on the x-axis, but at whatever the lower interval is. So because my lower interval here was, like I say, or the lower limit of my first interval was 15, that's where I'm going to plot my first point. And like I say, it's at a cumulative frequency of 0. So I start on the x-axis. Your first coordinate should always be on the x-axis and at the lower limit of your first interval. Now, when we go and draw the rest of our points, what we do is we take the upper limit of each interval and we plot the cumulative frequency. So for example, the first coordinate I'm going to plot is at 25, 8. The next coordinate I'm going to plot, 35, 22. The third coordinate, 45, 44, etc., etc., etc. Upper limit of each interval, cumulative frequency. Those are the points that I plot. Right, so if we quickly do that, obviously we're going to try and get as accurate as possible. Every 3 blocks that I have here, obviously I haven't put this properly now. So every 3 blocks is 5. So 25 will be over here, and we go up to 8. Now, guys, obviously get it as accurate as you can. It's never going to be perfect, but we try our best. 35, 22. Sorry if you can hear me muttering to myself. I'm just counting. All right. So there is our O drive. It's a curve. It should be sort of a J shape. Okay. Something like that. And that's it. Okay. Done. One thing I just want to point out in terms of like a visual thing on your O drive, obviously there's a few things that we can find here, but we were asked previously what was our modal class, and we said it was at 45 to 55. On your O drive, you can actually tell where your modal class is. The biggest gap between points is your mode. So this would be our biggest gap, and this is the interval 45 to 55. So you can actually use your O drive to determine your modal class. Right, the other thing you can use your O drive for is to find quartiles. So for example, if we were asked to find quartiles of whatever, for whatever reason, we know that we've got 100 data points. So your median would be here at 50. And then you read down. Okay, you read down in order to get your median value. I don't know, that would be like 47 as our median. Quartile 1 would then be at 25 on my frequency. Again, read your graph, read down. That would be, I don't know, about 36 as quartile 1. Quartile 3 would then be at 75. Read your graph, read down, this would be at about, I don't know, 54. Okay, quartile 3. So again, you can actually use your ogive to get your quartiles. So you could then draw a box and whisker. I could ask you for the interquartile range. I could ask you, I don't know, how many people were in the top 25% in terms of age group, etc. You can read quartiles off of your ogive. Actually, you can read any percentile grouping off your ogive. We do usually ask for quartiles. Just remember to drop that line down and actually read off the X value, read off the age or whatever variable it is you are working with. Right, so your ogive mark allocation, you always, whenever you draw any sort of graph, algebraic, trigonometric ogives, you get a mark for shape. Okay, it needs to have the curve. It should, 90% of the time, it's going to be sort of this like stretched out S shape. You get a mark for plotting correctly all your upper limits. And you get a mark for your grounding. Okay, so like I said, this is often where we make a faux pas, but that is a mark, so don't mess it up. Lower end of your first interval and 0. So that's your 3 marks for your ogive. So I'm just going to wait here in case you want a screenshot. Lorato?
Ma'am, so how likely is it that they would make us draw a box and whisker after drawing the graph?
We actually had this conversation the other day. Like, our sort of team thinks that a box and whisker is likely to come up this year. After drawing a graph, I don't think so. If anything, they will ask you to draw a box and whisker from a given ogive, or they will give you a box and whisker and ask you questions based on that. We think that it might come up. Obviously, like, that is just what we think. We have absolutely no idea what's going to come up. That's just our suspicion. But like I say, if we've already drawn an ogive, probably not a box and whisker as well. It's a lot of drawing. If you do draw a box and whisker, we will have given you the ogive, or like I say, we'll give you the box and whisker and ask you to answer questions based on that. Okay, cool. Alrighty. So 1.5, and this is again, like, it's not a hard question, but this is where we have a moment of oopsie. Lorato, is this a new hand or is it
Sorry, ma'am, I have another question. So, ma'am, when we're drawing the ogive, do we have to include a heading? Because I remember for my prelim I had to.
I've never seen a mark allocation for heading of an ogive. I mean, technically, any graph you draw that has to do with data, you should have a heading, yes. I've never seen a mark allocation for it, but probably not a bad thing to just put a heading in.
Okay, thank you, ma'am.
Okay, sure. Alrighty, so 1.5, like I said, not a hard question, but it's a question where I think there's now a lot of words and we get overwhelmed. Maths, we've trained our brains to not want words in maths, which I think is also why finance sometimes doesn't always go well, because there's so many words. So it says the Congress discovered that a mistake was made and 3 people counted in the range 45 to 55 should have been counted in the range 35 to 45. Calculate the estimated average age of the people who attended the Congress after the mistake was corrected. So let us just take our table so that we know what we're working with and just chuck it here for ourselves. There we go. Just move my water bottle so that we understand what it is that's actually being said to us. So if we go again, they are saying to us that, let's get a nice contrasting color here. 3 people that were initially put into this interval should have actually been put into this interval. So we need to take 3 of these people of 37 and we need to move them to the interval before. So we need to add 3 here and we need to subtract 3 here. That's what that information is saying to us. And now this question is going back to, like, you learned this way back when in like grade 8. We do it consistently, but going back to how to work out an estimated mean. So to work out your estimated mean, what we do is we take the midpoint of each interval. So we take the midpoint of 15 and 25, which is 20, and we times it by the frequency, so 8, plus the midpoint of 25 and 35, which is 30, times it by its frequency, 14. Frequency, not cumulative frequency, frequency, plus 40, midpoint of the next interval, times now the new value of 25, because we added those extra 3, plus 50 times the new value, because we took 3 away, of 34. And so we keep going. Plus 60 times the frequency of 16, the A value that we worked out, plus 70 times the frequency of 3. So estimated mean is the midpoint of each interval times the frequency added together, divided by the total number, which we know is 100. All right, so if you've forgotten how to work out an estimated average, yeah, this question is hard. But estimated mean, we take the midpoint of each interval and we times it by the frequency, add them all together, divide by your total number. And so in this case, the estimated average age was 44.5 years. You don't have to write years, you can just write 44.5, it's fine. But that is our estimated mean. All right, so I'm just going to put this here, estimated mean from group data. Is found by taking the sum of midpoint times frequency divided by your total number of values. Okay, you have to know that. That is just something you have to know. We have been doing it since grade 8. You start learning about group data and estimated mean in grade 8. But this is something you have to know and you have to be able to work with. The amount of kids who weren't able to answer this question was a little frightening. But anywho. Alrighty, so generally we do ask you a question like this, like a mistake was made, or we added to the Congress, or we added to our data set, we took away from our data set, something happened, and we ask you to then answer a question. Not hard, just understanding what is being asked of us. Okay, so let's take a screenshot of this last one, and then we'll have a look at the next question, which is more grade 12, least squares regression line, correlation coefficient, that sort of situation. Okay. So the scatter plot below shows the number of heaters a company sold per month and the average temperature of that month in a certain year. So we've got the table with the temperature and the number of heaters, and then we have a scatter plot. Remember, scatter plots bivariate data, so it shows 2 pieces of information at the same time, and we've got our scatter plot there. Beautiful. So 2.1 says, describe the correlation between the number of heaters sold and the average temperature per month. Verify your answer by referring to the correlation coefficient. So guys, this is where you would have to type your data into your calculator. You might as well get it done in the first place because you're probably going to be asked for other pieces of information at some point anyways. And so you need to type in your data. Now, as tedious as this is going to be, I am going to type it in with you. Yes, let me type it in with you. Right, so start typing in your data. If you have no idea how to do that, let me pull up a calculator and just put it on the screen for us. Boom, boom. Okay, there we go. So we're going to fill in our data. Mode, stat. Because it is bivariate, we go to this option 2a plus bx, because that's talking about least squares regression line, which is a scatter plot, which is bivariate. So option 2, and then you've got x and y. Now, grade 12, it doesn't have x or y here, but your first set of information will be x. So temperature is x, number of heaters sold, y, and we just fill in the data. I'm not going to say this. So whilst I'm typing, you need to be typing in the data as well, and then we'll have a look. Remember, once you've put in a data point, you push equals to enter it and move on to the next one. Right, all my data is in. I'm going to give you one more minute though, because I understand we might just take a little bit of time. So one more minute and then we're going to go. Okay. Right, so guys, once all your data is inputted, it's done. I know it seems like panic, but we push AC. That data is stored. We don't need to stress about it. So the first question is asking for the correlation coefficient. So we go shift 1, because there's a little stat in yellow above 1. And we are looking at regression. Okay, so we click 5. And we are looking right now for R. So we select option 3. That gives us our correlation coefficient. Now let's just double check a few things. Firstly, if we look at our scatter plot, these points are pretty close together, so it makes sense that it's a strong correlation. It's also a negative trend, it's decreasing, so it makes sense that R is negative. So in describing, we're going to use that little summary that I put up earlier, and we're going to describe our correlation. So we can say this is a strong negative linear correlation. We only talk about linear correlations, but there are other types, so it's always important to just be clear. Correlation. And it says verify by referring to the correlation coefficient, R equals 0.97. Be careful of your rounding here. So here are your marks, mark for the description, a mark for your R value. Right, 2.2 says determine the equation of the least squares regression line for the data. So remember, your least squares regression line is y equals a plus bx. Now, we've spoken about this before. This is 3 marks. So your marks are A, B, the equation. You are welcome to go straight to the equation, but what you need to understand is that if you mix up A and B, you're going to lose those marks. Okay, so rather write down A equals, B equals, therefore Y equals, and get your marks like that. Right, so if we just pull up our calculator again so that we can do all of that. There it is. Again, we go shift 1, regression, and we now want option 1 and option 2. So I find A first equals 104,795. It didn't say to how many decimal places, so generally we round off to 2, which we'll do in a second. And then we get B, so again, shift 1, regression, option 2B, push equals, make sure you push equals, negative 3,819. And so now Y is equal to A, 104,80 minus 3,82x. And we have our least squares regression line equation. Lati, I think I saw your hand. Question? Are we good?
Oh, hello, ma'am. Sorry, I wanted to ask about the rounding off, but yeah,
Okay.
since you said, yeah, thank you.
Okay. So guys, in terms of that rounding off, if we don't tell you, round off to 2 decimal places. Sometimes we do say determine the least squares regression line for the data rounded to, I don't know, 3 decimal places or to the nearest whole number, whatever. And then we do as we're instructed, but otherwise just 2 decimal places. Okay, so like I say, the 3 marks here, you get a mark for A, you get a mark for B, and you get a mark for equation. So rather write down your values of A and B separately so that we know what you're doing, and then that. Right, question 2.3 says predict the number of heaters sold for a month where the average temperature is 20 degrees. Now remember we said in our table, temperature is X, number of heaters sold, Y. It's always X first, then Y. So I want you, 2 minutes, I want you to tell me what prediction of the number of heaters are going to be sold when it is 20 degrees. Nice, guys. Okay, so all we do is we substitute into our equation we've just found for X. So substitute in 20 in place of X, and you get Y is equal to 28,4, which means that we're going to sell approximately 28 heaters. Remember, heaters, number of heaters, that is a discrete data point or data value. You can sell 1 heater, you can sell 2 heaters. You can't sell a quarter of a heater. So we round off, and again, we've had this conversation, write down the decimal. So like I've done, Y equals 28,4, and then do your rounding off. You have both options, then you're fine. Okay, we don't round up because it's not 29 heaters, it's 28. And yeah, like I said, we have had these conversations. So not a new conversation, but like I said, just write down both if you're not sure. And you should be writing down both anyways. So mark for subbing, a mark for your answer. Right, 2.4 then asks us to draw the least squares regression line. Now, I did, once again, have this conversation with you at some point. It was definitely after the trials because this is why I had the conversation with you. Can't remember. It was when we went through trial papers. Okay, so, Mhlasia, do you see your hand? Just give me a second. So when we draw our least squares regression line, firstly, it must stay within the domain. So it cannot extend past the extreme ends of our data set. It also must follow the trend. Okay, so when we draw this line, it must follow the trend of my data set somewhat perfectly. Okay, you can go and work out the specific point it must pass through. It's the average of X and the average of Y. So you can go work out the mean of X and the mean of Y, and that point it must pass through. But the general rule of thumb is not this nonsense that I've drawn, is that there should be an equal number of points either side of your line. So let's just fix this. There we go. That's a bit better. So you can see above my line, I've got 1, 2, 3, 4 points, and then below 1, 2, 3, 4, 5, 6. Okay, evenish. Above and below, we should be good. Mhlathi?
So, like, ma'am, when I draw my regression line, can I use the formula and then substitute my X values down there? Like, and then
Yeah,
basically
you can.
draw that. Oh, okay. Thank you, ma'am.
Yeah, that's fine. So if you want to get it like super, super accurate, you definitely can if you want to. All right, but the 2 marks here were basically for drawing it within the domain. And in this case, it had to pass through, in order for it to be even, it passed through 2 points, and I think it was these two that it needed to pass through, but basically an even number of points either side of your line, more or less. Alrighty, so 2.5 says calculate the standard deviation of the numbers heaters sold. Now, I want to show you this on your calculator because I think sometimes we panic and we think, oh no, I have to put in all my data again. No. Okay, so let's deal with this first. Sorry. So Lelo's asked, how will we calculate the exact point in order for us to draw the line? So the exact point that this line should pass through is the average the average of X and the average of Y. So on your calculator, again, we go shift 1, all of that fun stuff, regression. And 4 and 5 will give you the average of your X variables and the average of your Y. So you can click 4 to get the X coordinate, click 5 to get the Y coordinate, and it should then pass through that point. You could then technically substitute in any X value to get coordinates, but it should always pass through that mean point. Okay, so I hope that helps. Awesome. Right, so 2.5 is asking for standard deviation. Now, standard deviation in our head kind of goes back to, well, that's grade 11 work. So that's not where I'm using regression. That's where I would have said variance on my calculator. So I would have selected different option. But you've already put in data. So again, we go shift 1. No, let's try that again, shift 1. And instead of clicking regression now as my option, I go to variance. I go to option 4, and I can get the standard deviation. Now, remember, standard deviation is this little circle thingy with the little thingy on top. I know there's a word for whatever this Greek letter is. For the life of me, I can't remember what it is. I want to say it's delta, but I'm pretty sure it's not. It might be. I don't know. But that, done us. We want the standard deviation of the number of heaters. Number of heaters was my Y variable. So I go to option 6. That is the standard deviation of my Y variable. If I wanted the standard deviation in temperature, I would go to option 3, standard deviation of my X variable, temperature. So you can still do this all, even though you were working with bivariate data. So we click option 6, equals, and my standard deviation here is 34,13. Now remember, guys, standard deviation is your spread about the mean. So it's telling us how spread out our data points are around our mean point. That is a full 2 marks for just writing that down, nothing more. All right. So this question, honestly, straightforward as anything. This was 2, 4, 6, 8, 9, 10, 11 marks. 11 marks, easy peasy. Genuinely, I don't feel there was anything tricky in this specific question. The question before, the change in the age group, that was definitely a little bit tricky, but like I say, stats is the one section we should be banking marks, and analytical, which we're going to look at now in a second. Right, so take a screenshot of that, and then let's get into our analytical. I know we are moving at a pace, and that's why I say just ask me questions as we go along. But like I say, these are the easy sections. These are the sections we should be banking our marks. All right, so screenshots, and then I'm going to move. Okay, so let's have a look at some analytical. Now, like I said, guys, go back to the last number 1 question. There we go. Sorry. So if you still need to screenshot 1.5, there it is. While you're doing that, just in terms of the analytical, it generally starts off with a nice, easy grade 10, grade 11 level question, angles of inclination, gradient distance, like basics, and probably a quad. The next question, which is generally question 4, 5, depending how we've gone, but generally question 4, will then be on circles. Okay, so we need to, as I've said, be able to do all of that. And like I say, generally the first question is the one where we can bank marks, but realistically throughout analytical. So in the diagram below, A, B at -2, -7, C at 4, 0, and D are the vertices of a kite. Now, I'm going to just stop right here. Whenever we tell you a quad is something specific, so I've told you it's a kite, you can now assume all properties of a kite are true. So you can now assume that its diagonals, intersect at 98 degrees. You can assume that adjacent sides are equal. You can assume that one diagonal bisects the other, etc., etc., etc. So the second I'm telling you it is something, all of the properties should now apply. Right, E is the midpoint of the diagonal BD. So if we just go to our diagram, oh, come on, you silly thing. Diagonal BD, midpoint. So here's my diagonal. And if E is the midpoint, it's cutting it in half. So there we go. That's one of the properties of a kite. And AC is perpendicular to BD. I don't know where I was going with and E. Yeah, okay. I don't know. Lost a little bit. It's cool. It's fun. Right. The equation of AC. So this is the other diagonal in my diagram over here. Is y is equal to a half x plus 2. And here is AC. Okay, that is the information we've been given. First question says determine the length of BD. It doesn't say that. It actually says determine the equation of BD. Helps if you can read the question. Alrighty, so equation of BD. I'm sorry, it's coming up. Usually, when we are finding the equation of the line, we want to know 2 points that exist on that line, and we want to work from there. Now, the problem is I only have the coordinates of B. Okay, so if we have a look in terms of what we want, the line BD is this purple diagonal that I've highlighted. I know B, but I don't know D, and I don't know E. I don't know what the midpoint is. So I don't actually have 2 points on this line to be able to find the gradient and substitute in whatever. However, I do know that the equation of AC is y equals negative a half x plus 2. Now, this is important because AC is perpendicular to BD. I can use that information to work out my gradient because, and this is really important, this comes from like grade 10 analytical. The gradient of AC times the gradient of BD must equal -1 because they are perpendicular to each other. And this is a basic rule that we need to remember in terms of perpendicular lines. Now, obviously, you can go and work it out if you want and do all the inverse operations, but there's a little trick. What we do is we take the gradient that we know, and in order for us to find the gradient that is perpendicular, the gradient now of BD, we flip the fraction. So instead of 1/2, it now becomes 2/1, which is just 2. And we change the sign. So this gradient is negative. It's now positive 2. So now we know the gradient, which is great. Y equals 2x plus c. And all I need to now do is find my c value. To find my c value, I substitute in a point. Now, the only point I know on this line is point B. That is what I substitute into this equation. -7 is equal to 2 times -2 plus c, and I get my c value. So c is equal to -3, and so y is equal to 2x minus 3. Now, if you go and have a look at your line, it makes sense. It does have a negative y-intercept, and that would be at -3 now. So you can use the information that you've been given on your diagram to kind of guide you in making sure that your answers are correct. It is also an increasing straight line, so it makes sense that the gradient is positive, etc., etc. So your marks here are using the perpendicular rule, and you kind of need to state that rule somewhere or show that you know the product must be equal to -1, getting the gradient, substituting in your point, and your C value. So that's 4 marks, but 4 easy marks that we can bank. Okay, 3.2 now asks for the coordinates of E. Now, we know that E is the midpoint of BD, but once again, the problem arises that I don't know what D is. So I can't use the midpoint formula. I can't find the midpoint of a line segment where I don't have all of the information. So now we have to think about what else is E. So yes, it's the midpoint, but it is also a point of intersection. So let's just grab a little color here so that we know what we're talking about. So E is the midpoint, but it is also the point of intersection between the diagonals. Okay, I'm using shorthand between diagonals AC and, okay, that's way too many, whatever's that is. Shame, this little and had a bit of a moment. And BD. Point of intersection, think back to function. So we're bringing in some paper one knowledge here. Point of intersection means make your equations equal. We have the equation of the straight line AC. We've just found the equation of the straight line BD. We can equate them. So negative a half x plus 2 is equal to 2x minus 3. And we can now solve for our point of intersection. And guys, this is one thing that we often forget, points of intersection in analytical geometry. It is a very, very useful methodology to be using. And particularly in a case like this where I actually have no other option, remember points of intersection. Okay, we can bring in these paper one concepts into analytical. Right, so I've equated it for you. That's one of your 3 marks. So I'm going to give you 2 minutes to work out the rest of my coordinates. So to work out x and y for E. Nice, well done. Okay, so there it is. We equate, collect your x terms, collect your constants, solve for x, solve for y. All right. So like I say, mark for understanding that it's a point of intersection. So a mark for equating your 2 equations, and then 1 mark each for those variables. No working out marks, but it is quite a basic linear equation to solve. All right. 3.3, I'm going to be honest. This one stumped me, but just because, again, I didn't read the question properly. So it says, if the ratio CE to AE, and again, let's just grab a pen here. So CE to AE. If that ratio is 1:3, so here's 1 part to 3 parts, determine the coordinates of A. So this bad boy over here. Now, guys, this is a distance idea, proportion, lengths, distances. So essentially it's saying is that whatever the difference from point C to point E is a third of whatever the distance from A to E is. Now let's have a look at this. So E we have just worked out, I don't know why I did that, to be at 2, 1. 2, 1. If we look in terms of X, from 4 to 2, that's 2 units, which means that if this represents one part, every part I move represents 2 units in terms of x. Okay, I'm going to say this again. So E is at 2, 1, and the distance from E to C in terms of x is 2 units. Now, if E to C represents one part, it means that 3 parts over here, I need to work with a 2. So every part is 2 in terms of x. So 3 parts would be 6 units in terms of x. So from E to A, I would need to move 6 units in terms of x, because 3 parts, 2 units per part, 6. So if E is at positive 2, 6 units to the left takes us to negative 4. So the x coordinate negative 4. And then we use the same logic for y. Okay, so if we have a look at y, from E to C in terms of y, that's only 1 unit. So basically every unit is 1 part, or every part is 1 unit. And so what that means is that from A to E, we've got 3 parts, so 3 units. Now, if E is at positive 1, 3 units up is at positive 4. Okay, so we had to use the parts and the ratios in terms of x and in terms of y in order to go and figure out where our coordinate would lie. Again, not a hard question once we actually understand what it's on about, but understanding parts, understanding ratios, like way back to grade 8, understanding ratios and then understanding what it is that we need to work with. So I'm just going to write it out algebraically, just in case that wasn't making sense as I explained it. So what we worked out is that in terms of x, so in terms of x, from C to E, it was a distance of 2 units, which means that one part, because that was C to E's ratio, CE, one part, equals 2 units. So therefore, 3 parts, that's not a 3, is it? No. So therefore, 3 parts, which is the EA, 3 parts, must be 3 times 2, so 6 units. So I need to go from E and move 6 units to get to A. And it's the same logic with regards to Y. Y was only one part because the distance from C to E, 1 unit. And so 3 units now would be 3 units up. And 3 units up from E takes us to 4. Right, so it's just, like I say, understanding ratios, which isn't necessarily a tricky thing, but I know that from grade 8, many of us don't like ratios for whatever reason. And so here, just a mark per coordinate. Right, so I'm going to ask you to screenshot. And then in the last 5 minutes, I do want to at least have a look at a circle question. And then, Lelo, you can just let me you can just let me know in the chat if you can stay for 5 minutes for me to explain those questions for you. If you can't, just let me know and I will do an explanation and put it onto Google Classroom. Okay. Okay, so let's have a look at a circle. So in the diagram, the center of the circle is n at 2m, where m is less than 0. Now again, logically, this makes sense. We can see that coordinate n is in quadrant 4. That's where x is positive, but y is negative. So m must be less than 0. The radius of the circle is 17 units. Point R is at negative 13, 5. So we've actually been given this coordinate. And point S is at negative 13, negative 11. So also been given that coordinate. 411A, thanks Lelo, says determine the numerical value of m. So basically find the y coordinate of the center. Now guys, there's a couple different ways that you can do this, but my instinct or your instinct should be, let's substitute in what we know into the equation of our circle. So remember, the equation of your circle is x minus a squared plus y minus b squared, where a and b represent your center coordinates, is equal to r squared. So let's sub in what we know. We know the x coordinate of our center. That would be x minus 2 squared. We don't know the y coordinate. We know that's the m we're trying to solve. Don't know why I did that. We don't know the b coordinate. That's the m we're trying to solve. And we know the radius. It said in the information of the question, the radius is 17 units, so 17 squared. Okay, I'm getting somewhere. In order for me to solve for m now, I just need to substitute in a coordinate to replace x and y. And we've been given two coordinates, r and s. Doesn't matter which one you choose. I'm going to go with r, but obviously you could do any coordinate that you want. And so x is negative 13 minus 2 squared plus 5 minus m squared is equal to 17 squared. And now you have an equation in terms of m. All right, negative 15 squared is 225. We would have to distribute out this bracket, so 25 minus 10m plus m squared. Just remember, this bracket squared would be 5 minus m times 5 minus m, so you need to FOIL, or you need to distribute, is equal to 17 squared, which is 289. And now we solve. Because of the m squared, I know it's quadratic, so m squared minus 10m, and if I collect all of those like terms, I end up with 39. I will check my maths. Negative 39, sorry. Not positive. What a nonna. Negative 39. And now I factorize. Now remember, grade 12s, you have the quadratic formula. So from this point, you could substitute it into a quadratic formula. It is actually quite an easy one to factorize. M minus, she said it's so easy, m minus 13, m plus 3, because 13 times 3 is 39, and then negative 13 plus 3 gives us negative 10, equals 0. And so m equals 13, or m equals negative 3. Now, importantly, m is less than 0. So we eliminate our solution, or you just leave it out completely, and we know that m is at negative 3. So now I know that my coordinates here are 2, negative 3. And so now in B, when it says determine the equation of my circle in the circle form, easy. X minus 2 squared plus y plus 3 squared. Remember, the signs are always opposite. So if your x coordinate of your center is positive, when you sub it in, it becomes negative, and vice versa, is equal to r squared, which is 289. Okay, so once we had that center, super, super easy to go and work through. So just the mark allocation. I was going somewhere with the statement, but obviously can't really remember where I was going with that. Substituting in, what do we substitute in? So we substituted in 2m and substituting in your r value, 2 of those 4 marks, getting it into standard form, 3rd mark, getting your value for m, 4th mark. Obviously this one, 1 mark, you're just chucking it into the equation, and that's 5 easy marks on circles. Okay. Right, I am aware of the fact that it is 7 o'clock. Okay, right. It is 7 o'clock. We have done the basics of a circle, and I do understand that some of you need to leave. I also don't want to waste your time, and Lelo has said that they can say for need to go through those questions, so I'm going to do that. Guys, just remember, analytical, you can do it. All right, go through past papers, go and have a look, and obviously as you come across questions, if you have them, please ask. All right, I'm just going to wait there for you to screenshot. But Lelo, I'm just going to grab those 2 questions that you asked me. They were actually very nice questions. It took me a second to just like allow my brain to process. But let's have a look. Obviously, any of you, if you would like to stay to see the questions and for my explanation, you are most welcome, but you also don't need to. I'm just going to go right to the end here. Okay, so this was the first question. And the second question was this cool number pattern question. Righty-roo. Okay, so I'm just going to start with the first one, and then we'll go from there. So it said solve for x in terms of y. So basically, we need to end up with a situation of x equals. I'm going to be honest, I had absolutely no idea where I should start, but because I've got x trapped in the brackets, my first inclination is get x out of the brackets so that you can isolate it. So I'm actually going to distribute both sides. So this becomes x squared minus 2x minus 3 is equal to y squared minus 2y minus 3. Okay, now immediately this is helpful because I've got a minus 3 and a minus 3 on both sides. So they basically fall away. Because if I brought one over, I would have minus 3 plus 3, 0, done. So I can drop those constants immediately. So now I've got x squared minus 2x is equal to y squared minus 2y. Okay, so that's good step so far. Now, generally, our inclination is to go and, I wonder if this would work. Let's see. Keep the like terms group. So on the left-hand side, I can factorize out an x. But again, now the problem is I've got an x outside the bracket and x inside the bracket, so I'm actually not feeling that situation. So let's have a look at what else we could do. If I brought the y squared over, that would become negative y squared. And then I would have the difference of squares. So x squared minus y squared, difference of squares. And if I take this 2x over, it becomes positive 2x minus 2y. Now, I know I'm on the right track here because difference of squares, x minus y, x plus y. And on the right-hand side, I can factorize out of 2, x minus y. So now this is great because now what I can do is I can divide both sides by the common bracket, and I can get rid of that. So x minus y divided by x minus y divided by x minus y. And so we get rid of one of the x's that we didn't really want. And so now we've got x minus y. Also lost my marbles a little bit. So let's just try and cancel out the appropriate terms here. Sorry, my boyfriend wanted to come in to grab a jacket and I just was not concentrating. Okay, so we cancel out the x minus y's. There we go. And so what I'm left with on the left is x plus y is equal to 2. Now this is a beautiful linear equation. I can solve for x. I'm going to subtract y on both sides. And so x is equal to 2 minus y. Right, like I said, I'm going to be honest. When I first looked at this, I was like, no idea what to do. But there's a couple things that we need to think about when we get questions like this. A, if you are solving for a single variable, your goal is to get one term with that variable. Because like I said, we had 2 brackets with x in it. We need to get them out of the bracket so we can start to simplify. Now, like you saw when I was doing this, my first inclination was to rather factorize right at the start here by taking out a common factor of x and a common factor of y. But the problem is I still then have an x outside and an x inside. I don't want that. And so I had to look for another solution. Often these questions, because this was probably, I'm assuming, one of the last questions in question 1, it's a complex question. It's supposed to test you. You're supposed to trial and error a little bit. But again, we start to think ahead. We should be able to see that because I've got 2 squared terms and then an x and a y, maybe difference of squares is the way to go. And we get from there. So this was a very nice question. I mean, obviously you might not feel that way, but like I say, the goal when solving is to get one single term with that variable in it, and then we can do our inverse operations from there. Right, I'll just wait in case you want to take a screenshot or if you have any questions about this. Otherwise, we'll have a look at this number pattern 1. Again, took me a second to understand the number pattern 1. I struggle with these types of number patterns. There was a question, I don't want to say it's similar to, but same concept in NBT. But yeah, Rato?
Ma'am, for this first question, will it be asked maybe, you know, with algebra, there's the 1.1, those 1.1, 1.2. Will it be asked like when they group the algebra questions, or will it be like a standalone question?
This would probably be a standalone question because, like I say, this would be a complex problem-solving question. So it'd probably be right at the end, 1.3, 1.4. Lelo can tell us what the numbering was. Actually, I don't know why I'm saying that. It was 1.3. Yeah, standalone question. Cool. All right, so this number pattern, like I say, not my favorite. I acknowledge this is not my strong suit. However, I was going somewhere with this. So it is a series, so we're adding and subtracting, but what we kind of need to pick up is what are we doing? Now, obviously you could group this in so many different ways in terms of grouping your terms, but if we have a look and we group according to plus signs, these are consecutive integers. So 1, 2, 3, 4, 5, 6, 7, 8. We're adding the difference of consecutive integers. 399, 400. So we kind of, whenever we get questions like this, we kind of have to see what is the pattern. What can I group together? What can I not group together? How do they work? And the reason I'm specifically grouping the differences is, again, difference of squares. Right, so this first situation, I can factorize to 1 minus 2, 1 plus 2. This next situation, I can factorize to 3 minus 4, 3 plus 4. That's a 3, so sorry. The next one, 5 minus 6, 5 plus 6. Hopefully we get the picture. And we can get those solutions. So 1 minus 2, negative 1, times 3, negative 3. 3 minus 4, negative 1, times 7, negative 7. I have some regrets about how I've chosen to write this, but I'll write it now. I'll write it properly now in a second. 5 minus 6, negative 1. So hopefully we're seeing a bit of a pattern here. It's always negative 1 times something. 5 plus 6, 11, negative 11. So if we write this out as a sequence, my first term was negative 3. Then I had negative 7. Then I had negative 11. And hopefully what we see here is this forms an arithmetic situation. Now remember, we've grouped them. So in between each of these is the plus sign that I kind of use as my distinction between groups. So this is an arithmetic sequence. That's not how arithmetic sequence. And if we have a look, what we're doing each time is we're subtracting 4. Negative 3 minus 4, negative 7. Negative 7 minus 4, negative 11. And so we are starting to find our pattern. So the question said evaluate, which means find the sum of. And so, sorry. And so we essentially need to go and find the sum of. Now, the problem is I don't know yet how many terms I'm adding or subtracting to. So we do need to go and work out this final bracket over here. So we'd have to find whatever 399 minus 400 times 399 plus 400 is. So obviously 399 minus 400, negative 1, times 799, negative 799. And so that would be my last term that I add in this sequence. Okay. So now that I know what I'm adding up to, we can go and find the sum. Now, I feel like we spoke about this in class, but there is, if you know the last term of an arithmetic sequence series that you are adding up to, there's like a separate little formula that we can use, which says the sum of n terms is equal to n over 2 times your first term plus your last term. Now, obviously, if you don't remember the formula, that's fine. We did a question earlier where we figured out how to work out what that value of the last term is using Tn. You can do that. But this little formula, if you do know the last term, is quite useful. Because now we can go and work out, what are we trying to work out? Oh, the sum of. So now we can go and try and work out the sum. Now, I don't know where I'm going with the statement. Obviously I'm having a bit of a moment here. Oh, we need to figure out how many, sorry, geez Louise. We need to figure out how many terms we're adding here. So remember, we've grouped terms. So there were 400 things that I was adding, but I'm grouping in groups of 2, which means technically I'm adding 1, 2, 3, 4, all the way up. So every 2 terms is one group. And so I'm actually adding 200 terms here. So n is 200. And so we can substitute in all we know, a being -3 and the last term being -799. And from there, we just chuck that into our formula and we get an answer, which is 200 over 2, -3 minus 799, -80,200. Right, so quite a nice question, I think. But obviously it is reliant on you seeing the pattern. And like I said, I don't think I would have, like in a stress-induced situation, like an exam, I'm not sure how quickly I would have seen the pattern. But like I said, go back to your algebra. So like I said, I grouped this specifically because I was thinking of difference of squares. And it worked out. Again, this is obviously a problem-solving type of question, and so meant to be a little trickier. But like I said, when deciding how to approach these questions, just think back to your algebra and think back to what makes sense. At the end of the day, you want to try and group it so that you get some sort of pattern that you can work with. And so, yeah, your first grouping might not work out, but just have in the back of your mind, how can I simplify it so that I can get a number pattern that I can work with? And like I said, just because of the squares here, I immediately thought of difference of squares happen to work out. All right, so I hope that all makes sense. 2 very nice questions. So thank you for asking them. Like I said, very, very nice questions. Appreciate it. Again, I'll just wait in case you want a screenshot.